Hello, everyone, and welcome to our webinar. My name is Raina, and I'm on the marketing team here at BigPanda, focusing on our events and webinar strategy. Today, we're putting a spotlight on the topic of machine learning and how it can help your NOC with the battle against alert storms, ticket overload, and MTTX problems that they're facing. I'm here today with my colleague and ITOps veteran, Mohan Kampella. Mohan is the Senior Director of Product Marketing here at BigPanda, and today he will discuss some of the largest and most complex enterprises in the world and how they use machine learning to achieve the following. Number one, a reduction in ticket volume by 75%. Number two, eliminate alert noise by 95%. And number three, cutting down the MTTR, also known as mean time to resolution or remediation, by 85% or higher. And finally, how you can do the same in your own NOC. I'd like to encourage you to share your thoughts with us on social media by tweeting or posting with the hashtag BigPandaWebinar. So before we get started, Mohan, could you tell us a little bit about your background?
Yeah, thank you, Reina. Thanks for having me, and welcome everyone. So my name is Mohan Kampella, and I am a senior director in the product organization here at BigPanda. My background is that I've spent just under 20 years in the IT ops space. 11 of those years were spent mostly on architecting and deploying complex enterprise event management, event correlation, and ITSM tools in the space. So I work pretty closely with solutions like Netcool, HP OpenView, CA, BMC Patrol, BMC Remedy, and ServiceNow. I also ran a managed services practice, primarily focused on some of the tools I mentioned, and I'm happy to be here.
Well, thank you, Mohan.
Great. So with that, let's get started with the webinar today. Again, thanks for joining. The topic today is, how can your NOCs, or can your NOCs, win these classic battles against alert storms and ticket volumes using machine learning? And the answer, of course, as you can suspect, is yes, today you can, as long as you avoid a handful of common problems. And we're actually going to talk about that today. We're also going to be talking about how some of our largest customers have successfully overcome these issues and how they've actually become successful. We will be taking questions at the end. So if you have any questions, feel free to use the GoToMeeting or the GoToWebinar control panel to add your questions in. So with that, let's get started, Reina.
Yep, thanks.
All right.
Sounds good.
So the agenda, why does it feel like NOCs are fighting a losing battle? What can, obviously it's a formal agenda, what can machine learning do for NOCs? What have other real world companies achieved with machine learning? What are the 5 common problems they ran into, and how did they overcome them? So with that, let's jump in. So if you're in IT ops, or you work in a NOC, or you manage a NOC, it's pretty obvious over the last few years that it feels every single day like your NOCs are fighting a losing battle, constantly putting out fires, responding to P1, P2, P3 outages, pulling in resources outside the NOC, L2s and expensive L3s, super long bridge calls that seem to last 8 to 24 hours that involve up to 100 or 120 people. So these are, again, things that are very common in just a day in the life of practitioners and people that work in the NOCs. And I think if you look at, if you dig back in a little bit and try to understand, why that is happening, there's a couple of reasons we see. The first one is that, IT's role is changing. So if you go back 15, 20 years, IT was mostly in a support function, primarily tasked with keeping the lights on. Fast forward to 2018, and the role of IT has fundamentally shifted. In an age where every company is launching new digital initiatives and features and applications and services pretty much on a daily or a weekly basis, IT has become a prime driver and enabler of digital transformation. So what that means is that IT is now, very the success of IT and the success of IT ops is very strongly correlated with how successful someone's new digital initiatives are. Where IT used to be a cost center, today IT and IT ops are actively driving and responsible for ensuring new streams of revenue. Whereas IT was relegated to being, one part of the organization with very specialized mandates. Today, across every single function, every business unit, and every department, IT and the role of IT has become central to the success of new initiatives. Uh, in that context, what has happened is that, especially this trend has accelerated in the last 5 to 7 years, I think, is that, with the demands of digital transformation, infrastructure has transformed. Uh, so in terms of the cloud, containers, microservices, DevOps, the move away from monolithic applications, etc., infrastructure and software have both successfully transformed. But unfortunately, if you look at IT ops and NOCs, they're still held back with a number of legacy tools that were just completely that were never really designed to handle this modern infrastructure and software era. The result of that is, if you look at IT ops and if you look at network operations centers or NOCs, they're still very manual, slow and difficult to scale. One of the things we see is when we go meet with prospects and future customers, when we actually talk about the pain that is just an everyday fact for some of these NOCs and IT ops, and we show them a slide that is, or a diagram that is similar to this actually resonates very strongly. And I've actually I think back about my own experience, working inside of NOCs and deploying IT ops solutions for NOCs and training NOC personnel. Unfortunately, the problem has actually become worse over the last several years. If you look at if you look at this diagram at the very bottom, the number of siloed, fragmented monitoring tools has only grown in number. There's any number of new categories of tools that NOCs now rely on in terms of change management, topology, and CMDB, and so on and so forth. But in spite of all of that, if you look at L1s and L2s and L3s, they're constantly in a world of pain. They're constantly putting out fires. They're constantly triaging issues. MTTD, the mean time to detect, MTTA, the mean time to acknowledge, and MTTR, the mean time to respond, are all continue to be issues. So what that means is, when there's a critical P1 or P2 outage, then both the L1s and outside of the NOC, the L2s and L3s get pulled into these super long bridge calls. There's obviously a lot of interest in this, what we call the mean time to innocence, which is the time it takes for someone to determine that their change or that their group is not responsible for that outage. And all during this time, when there's an outage, when there's a performance issue, when there's a bridge call, it means that your customers are unhappy. It means that your business stakeholders are extremely unhappy because after spending months and spending millions of dollars launching a new initiative, when that has a multi-hour outage, if you're unlucky, that's going to land you in the headlines. If you're unlucky but not overly unlucky, you're still going to be facing a barrage of unhappy customers and unhappy business users that want to know why this P1 outage lasted 16 hours and why that meant that you potentially lost a couple of $100,000 or maybe a few $1,000,000. So net, I guess the takeaway here is that because of the changes in IT and because of the changes in the infrastructure and software, unfortunately, IT ops and NOCs have not transformed, and therefore they find themselves in a world of pain. Now, given that, we actually think that there is good news today, right? And which is the fact that thanks to the advances in machine learning is now an artificial intelligence, which is a superset of that. are finally at a stage where they can and they are actively helping, some of the largest NOCs in the world. So one of the common questions we run into is, if you look at industry, or if you look at Google AI, for example, if you're so inclined, you actually see that AI and machine learning and deep learning, etc., have been around for a few decades now. So the first question is, how do you know that this time around that's actually pragmatic, it's realistic, to actually make a difference and move the needle? So I think it's a confluence of factors. We don't necessarily need to get into that in a great amount of detail today, but in a nutshell, it is a fact that with the rapid decline in the cost of compute, storage, and other associated resources, machine learning has now, to some extent, I would say, been democratized and is now available at a reasonable price point to both large and small organizations. And IT ops is certainly an area, just because of the factors we discussed before. IT ops is an area that is primed to benefit from machine learning. So let's talk about four common things, or four ways in which it actually can tangibly make a difference. Machine learning can learn about your environment, and we mean the IT ops, the very noisy IT ops environment. Machine learning can handle both the so-called known knowns and the unknown unknowns in terms of incidents that the NOC has to manage, detect, and prioritize, investigate, resolve, and escalate. And the third point, I think, is extremely important, especially for large organizations, or a medium-sized organization that's very dynamic. And that's the fact that machine learning is extremely cost-effective and can help your NOC scale with the existing headcount that you have in real time, which is, I think, basically a game changer. And last but not the least, we all know, how NOCs are structured, right? You basically typically have, two, or maybe actually more commonly 3 shifts. You have during, quote unquote, what used to be, prime business hours, you would basically have the maximum number of people working in the NOC, and then during the graveyard shift, or maybe over the weekend, you basically have a skeletal crew that were keeping the lights on. So what we see is that in many cases, the NOC staffing structure hasn't changed, but customer expectations have changed. A few weeks ago, my mobile banking app was actually down for 48 hours over the weekend. And it's just unbelievable to me that at this day and age, something like, and this was a pretty major bank, it was incomprehensible that in this day and age, you could still have issues like that, because customers now expect your services to be available 24/7, 365, evenings, weekends, day and mornings, early morning, doesn't really matter. It's truly around the clock set of expectations that customers have. And therefore, what that means is that you need to make sure that your NOC can respond in 24/7, 365 as well. And that's where I think machine learning can actually have a huge impact, because machine learning can let your NOC autonomously respond to incidents on a 24/7, 365 basis. And that's where I think the NOC team and your machine learning powered AI ops or IT ops tool can work really well together and deliver a bunch of benefits for you. So now let's stop talking in terms of abstracts and talk about a very tangible, concrete scenario that NOCs face, every single day. Like we discussed a few minutes ago, NOCs have typically anywhere from 20, 30, 40. I think for us, the average number of tools that we find is between 40 and 50. So you have tools such as what you see here, App Dynamics, Nagio, SolarWinds, Splunk, and literally like any number of off-the-shelf, homegrown, or custom monitoring tools that are generating hundreds of thousands of alerts in real time, and these are now flooding your NOC. So with machine learning, we can make sure that we're able to, in real time and dynamically, normalize and enrich them. We can, suppress alerts based on, dynamic shifting, unplanned and planned maintenance windows. And most importantly, in this example, create the patterns that you need to correlate these hundreds of thousands of alerts into just a handful of incidents. The correlation rates, or the compression rates, as some people call them, that we typically see are anywhere between 85 and 95%. There's some talk in the industry about how vendors, achieve 99.9% correlation, or I guess, why stop with that, right? Why not go to 100 in that case? I don't think that's really realistic, because then you're basically doing some creative accounting there by, taking deduplication into account and so on and so forth, which is not really where you want to go. But reasonably and very pragmatically, large customers can expect machine learning to deliver between an 85 and a 95% correlation rate. Now, machine learning also has other things it can do. Once these correlations and the compression of the incidents happen, you also have probable root cause, which again, if you've spent any amount of time in the NOC, I mean, you probably recall that the holy grail of event management is root cause analysis, automated predictive root cause analysis. So your L1s and potentially your L2s and L3s know very easily where the root cause is or what the root cause is, and to be able to give them a very quick way to hone in on that so you can drastically slash your MTTR. So I think, again, just being in the industry, I tend to shy away from anyone that claims to basically accurately tell you what the root cause is in every single incident. I actually don't think that's reasonable. But what is helpful and what is doable entirely with machine learning is to identify probable root cause, which then cuts down your investigation time dramatically. So it's both the compression and the correlation and the probable root cause that I think are two areas in which machine learning can add a lot of value. There's other things too that we can do, but for the purposes of today's webinar, that's where we're going to focus on. So with that, let's get into a couple of our real world success stories with three large enterprise NOCs that have seen some very tangible benefits with machine learning in the last 12 to 18 months. The first one is a pretty large media conglomerate whose stated mission is to reimagine television, and they're literally a household name with any number of TV channels, video on demand, online streaming, and so on and so forth. And for them, the mandate was to radically transform their IT stack and move all of the legacy cable, offline, analog equipment that they had into an all IP stack. Obviously, the huge potential issue with that is availability and performance for all the existing properties and assets, while making sure that these new IP-driven services like streaming or video on demand were also performing really well at any given time. It's a hyper-competitive market, as you guys can imagine, so there's very little scope or room for error. So what they were able to do with machine learning and with BigPanda specifically is to connect 35 different monitoring tools across all of the various lines of business into the so-called single pane of glass. That's a term that I'm guessing many of you are familiar with. So that was obviously a foundational thing, because that meant that people in the NOC were not swivel chairing anymore, or basically going from monitor to monitor to monitor. More importantly, and in this case, their workflows are actually driven out of their ServiceNow ticketing system. And again, anyone that's been in the NOC can understand how your workflows can primarily be driven out of your ITOps event management tool, or they can be driven from your help desk and your ticketing systems. So in this case, the majority of the workflows were driven through their ServiceNow ticketing system. And what they were able to do is use machine learning to achieve over a 95% correlation rate in terms of the alert to incident ratios, which then downstream meant that their help desk now had 85% fewer tickets to troubleshoot and manage on a daily basis. In the process, they also, as you can imagine, saw a bunch of other benefits. The MTTR was substantially reduced, and this organization was largely SLA driven. So they ended up actually seeing a 53% improve in the SLA compliance. And they're planning to use this machine learning driven, BigPanda platform to improve operational efficiencies across other properties in the future. The second example we have is a large global semiconductor manufacturer. It's a Fortune 500 company, one of the largest firms in the world. And this organization had three global NOCs, which basically had a follow the sun model. In this case, the two very interesting statistics that they track against were one, using machine learning and the pattern matching that I talked about before to achieve a 98% compression ratio. So out of every 100 alerts that they had, that they were receiving, they ended up with 2 incidents that their L1s could now focus on. And the icing on the cake for them was that out of those 2 incidents, and obviously over the course of the 24 hours, they had a few hundred incidents like that. The L1 team across all 3 global NOCs was able to achieve a 99% compression rate. Specifically, how we did that was to drastically cut down the mean time to detect, which was a huge issue pre-BigPanda. We were also able to identify the probable root cause. So what that meant is that their L1s could now follow a simple series of steps to actually resolve something, or if they had a false positive, to rule that out before it was either sent to the ticketing team as a ticket or escalated to an L2 or an L3. They also had, deeper down the incident management funnel. We also helped them. This is a little bit outside the machine learning piece, but I think it's pretty important. Is they had a specific open source auto remediation or orchestration tool of choice, and we were able to integrate BigPanda with that, so they could then get very close to the closed loop automation model that they had in mind. So that's the second case study. Third case study, before we actually talk a little bit more about some of the problems they have, there's another large, multi-billion-dollar software tools provider that has over 10,000 employees in 35 countries. With them, both the MTTD and the MTTR were 2 big issues pre-BigPanda. Using machine learning, we were able to achieve a 73% correlation rate across all of the incoming alert streams. And again, this is after the deduplication phase. We also helped them share these machine learning correlated incidents easily with Slack and ServiceNow. There's deep, bidirectional integration with ServiceNow for easy collaboration, etc. And end of the day, we were able to help them achieve an 85% reduction in their MTTR, which has, obviously made a substantial difference to the efficiency of the NOC, primarily using our machine learning-driven BigPanda platform. Now, I mean, that's in terms of success stories, and I'm guessing you guys have all heard other success stories in the past, and that's great. Those are really good top line numbers. But as you can imagine, there's 5 issues that both that all 3 customers that I mentioned did encounter before, and something else that most of our other customers and prospects have encountered. So we thought we'd spend a few minutes talking about what those 5 issues are to make sure that you can obviously pick the right tools and wisely choose tools that can help you be successful. The first problem, and a very common problem, unfortunately, is that most machine learning tools are not transparent. So what that means is, having used, just going out on a limb here, having used a number of legacy rules-driven tools, where you're probably every time a new device comes on board, or maybe a new tool comes on board, you probably take some kind of SNMP MIB, you convert that into a rules file, and you integrate that into your ITOps tool. So instead of doing that, when you start looking at a machine learning tool, the first thing that happens is a lot of these tools are not very transparent. So what that means is, so let's say you correlate 20 alerts from a server monitoring tool and application monitoring tool. It's exceedingly difficult for the L1s and L2s and even the L3s to determine what the logic was that caused these 20 specific alerts to be correlated into that one incident, and why, let's say in that same time window, there were 3, 4, 5 other alerts that came in, why those were excluded. And this is, I actually think this is almost like a showstopper for many organizations, because unless you have that kind of a transparency, it's hard to agree or accept the results of machine learning. And then the next step is acting on those results also becomes a challenge if you don't have that transparency. So the bottom line is that when you pick a tool that uses machine learning to help your NOC, you absolutely we strongly recommend that you pick a tool that produces logic that's expressed in simple, plain English and in a format that humans can see and understand. The second issue, and this is something that you may already have started to see if you're in talks with other vendors, is the fact that machine learning typically takes a lot of data and therefore a lot of time to train to get to results that you can trust. So the problem with this is, unfortunately, most NOCs and most IT teams and IT ops teams don't have the time. They don't have the 6 to 9 months it might take for a brand new tool to be trained by months or hundreds of thousands of alerts that come in. So that's one issue. The other issue with this is the fact that because it takes a long time to train it, if you have and I think pretty much every single mid to large organization has this. If you have a lot of people that have especially L2s and L3s that have been working in the NOC or as part of the IT ops team for a number of years, they have a lot of tribal knowledge and business knowledge that you understandably want to incorporate into your machine learning tools quickly. So for example, you might know that in a certain data center, when you see alerts that come in from a specific firewall, you know, just based on the fact that you troubleshooted that 1,000 times, you know that that probably means that a certain switch has a port that is flapping, and therefore you want the network engineers to take a look at that without spending 3 hours on a bridge call. But if you have a machine learning tool that's not able to incorporate, that needs to be trained for many, many months, and you need to wait for it to encounter those patterns repeatedly for it to then determine that it's an issue and point to the root cause, that's wasted time. And I think philosophically, we feel that that's a wrong approach. So therefore, the way to get around that issue is to make sure that you pick a machine learning driven IT ops or AI ops tool that lets you edit the logic that the machine learning creates and also does not require months and months of training. So that's the second issue that we've seen others run into. The third issue that other prospects and customers have run into in the past is with machine learning, unfortunately, because it's such a opaque black box. I guess that's an oxymoron, because I guess a black box is opaque by definition. But the problem there is that there's really no way to test the logic that your machine learning creates. And testing, I mean, the two ways to get around that traditionally have been to unleash that into production and wait to see how it handles the next incident. Unfortunately, that's not a luxury that a lot of customers have, because when you're talking about new services being launched on a daily, weekly basis, you don't have that time. Also, more importantly, the other way to get around that would be to have a staging environment or some kind of pre-production testing environment where you recreate a subset of your infrastructure and basically have a bunch of tools generating simulated data. I mean, that could help to some extent, but unfortunately, as I'm sure the veterans on this call realize, uh, that's really not a very realistic way to replicate production behavior. So what we do and what we suggest is, or what we recommend, I should say, is you absolutely should pick a tool that lets you test and preview the results of your machine learning generated logic before you put it into production. And the way we do that with BigPanda is we basically have effectively a what if engine. And this what if engine, what it does as part of the machine learning implementation is that it lets you pick an arbitrary window of time, going back, to whenever in the past, and then you can apply your correlation pattern to that window of time, and you can see what the resulting correlations and the incidents look like. And if you think that, based on your existing tribal or business knowledge, if you think that that intended behavior is not quite what it should be, then you can tune it further, test it, and then uh, once you're satisfied that it's working the right way, then you can deploy that into production. So that's the third pitfall that you should definitely keep an eye out for. The fourth one, and this is a little more, I guess, psychological or psychology based, but in my experience, this is something that is, extremely important for NOCs is, L1s and L2s and L3s obviously want to be able to trust any new tools, especially given the black box problem with machine learning and AI. I think it's extremely important for them to pick tools where it's easy to build trust with. And it comes down to two things. So one is the problem with being deterministic or not. In simple terms, what that means is if you have the exact same set of inputs that your NOC receives, and your machine learning creates a different set of results every single time, that means that you have a problem with being deterministic. And as you can imagine, that is a huge red flag, because every single time you have the same set of alerts, because your, quote unquote, your rogue machine learning has, learned something new, it decides to handle these alerts in a different way by either suppressing a different set of alerts or creating an incident that points to the wrong probable root cause or whatever that is. That's going to obviously create a huge trust barrier, and it's going to really make your teams not depend on the tool, which defeats the purpose of investing in it to begin with. And then two, when you have a black box approach and you don't know how this black box driven machine learning tool works, that's a huge trust factor issue also. And that's where, we obviously, understandably, we're biased, and we actually think that our, BigPanda's open box machine learning approach is something that fosters trust and therefore adoption and success over the long term. Just to drill on that just a bit more, and I realize we're probably coming up in terms of time. We have 7 minutes. So we're a strong proponent of the teams and machine learning, or the human and the machine learning factors working closely together as being the path to success philosophy. So we think that our open box machine learning, in fact, if you look at the design philosophy, if you look at the features that let you preview, edit, test, and tune, that's the foundation that it's built on. And by giving you this open box machine learning driven model, we help you gain the transparency, the trust and control, and the predictability that we think NOCs need to be successful with these tools. The last one here is, I guess it's a no-brainer in some sense, but it's also at the same time equally important, I think. If you look at the industry, if you look at news, not even just ITOps, but if you just look at AI and ML, I think there's a lot of fear, uncertainty, and doubt in terms of what machine learning and AI can and cannot do. And this is something that we think every large organization and mid-sized organization should be cognizant of. You absolutely want to be pragmatic. You don't want to have unrealistic expectations. So in terms of the NOC and ITOps, what does it mean? No machine learning or AI driven tool is going to be able to give you, is going to be 100% efficient across the incident management pipeline detecting, investigating, prioritizing, remediating, and then escalating these incidents. I actually don't think the technology is right there today. And even if the technology were to advance, just based on the ever increasing complexity of IT ops and IT architecture, I think that would just be a completely unrealistic expectation of what machine learning and AI can do for you. So going in with those without those expectations is actually, I think, a pretty good determinant of success as to what you can and cannot accomplish with machine learning. So if you are interested in learning more about open box machine learning and how BigPanda can help your NOC and your IT ops teams, we're obviously here and we're happy to talk to you. You can always go online to bigpanda.io and take a look at our technology and how we can actually help you. If you're ready to see a demo or if you want to have a live discussion, then use the contact form there to drop us a note. Or if you're on Twitter, send us a message or tweet at us. We're at BigPanda. So with that, let's see if we have any questions that have come in, Reina.
Yeah, thanks, Mohan. Yeah, actually, it looks like we do have a couple of questions here. So let me go through them real quickly. So the first one is, what is open box machine learning, and how is that different from black box or opaque machine learning?
Sure. So that's a question we get asked all the time because at this point, I guess the phrase open box machine learning is not quite a household name.
Right.
And generally, when you think of machine learning, especially if you look at the media and the news, I think there's a lot of press around the fact that AI and ML have a black box issue. So, for example, you go on social media, if you go on not maybe Amazon.com, because I think they have it nailed down pretty nicely. But if you look at some of the other retailers out there, for example, you really don't quite know why the platform that you're using might be recommending that you read a certain article or you look at a certain post or maybe buy a certain item. Obviously, there's something happening in the background based on past behavior. Maybe it's something, in technical terms, maybe there's some kind of fancy matrix factorization that's going on, the result of which is a set of recommendations that you have no insights into how they were generated, but you're presented with the findings of that. So that's how a classic black box driven machine learning tool works. That is completely different from the open box machine learning model. In the open box machine learning model, we realized that classically machine learning has a black box issue. So what we've done is, from an R&D perspective, put a lot of time and energy into making sure that the results of machine learning are expressed, or I guess if you prefer the term, verbalized in human understandable terms in plain English. That's the first part of it. The next part of it is we want to make sure that you have full control on the machine learning algorithms. So we want to make sure that you can edit these correlation patterns and incorporate your business knowledge. C, or the third thing, is to make sure that you're able to test and preview the results of this. And then last but not the least, deploy them into production in a safe, staged manner. So those four things together form the basis of what we call open box machine learning, which is, again, the complete opposite of the black box approach that many other vendors have taken.
Okay.
Yep.
Thank you for that. The second question that I see here is, do I need to have data scientists or machine learning experts on staff to use machine learning for my NOC?
No, that's a good question, because we do get asked it a lot of times. And in fact, some of our very large customers will actually have someone from their data science team or someone from their machine learning team come and talk to us. And we're happy to have that discussion and talk about how BigPanda's open box machine learning actually works in terms, obviously, that makes sense, right? But from a pragmatic everyday use standpoint, again, our philosophy is that you should not need to have machine learning scientists or data scientists on your staff to be able to use this in your NOC. I think we're aware of, maybe over the last few years, we're aware of just a very small handful of companies that have tried to do something like that using like data science teams, but there's just a lot of domain knowledge that you need. That
Right.
what we've done is, we've basically eliminated that step of needing that kind of in-house expertise, and we've combined machine learning with that domain knowledge that we have, and we've packaged that into something that works out of the box, which is, again, the open box machine learning piece.
Right.
Yeah.
Okay. That makes sense. So how long does it typically take to train artificial intelligence or machine learning ops tools before they can start correlating these incidents?
Yeah, that's a good question too. That's also, I think, something that's a major concern for some of our large customers, because typically there is some kind of seasonal event. If you're a retailer, you might have Black Friday coming up. If you're not a retailer, but if you have, let's say, a major broadcast season coming up, you might have some kind of M&A activity that that means that you have a drop dead date by which you need to merge two different sets of architecture. So you really don't have the luxury of time, and you absolutely can't wait for 6 to 9 months to wait for the models to be trained. So, with BigPanda, with our open box machine learning, typically in 7 to 10 days, the model, so which is, in terms of the in enterprise time, I would say it's, basically out of the box. You get to a 65% correlation rate or so with our, machine learning.
Okay.
And then 99% of our customers start to see a correlation rate between 85 and 90%, 95% within 8 weeks of then going live.
Oh, wow.
Yeah, so I would say in the majority of cases, in under 3 months, you basically have, our machine learning models fully deployed, fully productive, and making a dramatic difference in the efficiencies of your NOCs.
Okay. I have another question here.
Yeah.
So it says here, when you say that you can actually see how decisions are made by the open box machine learning process, what does that actually look like?
So what that means is that the correlation logic that is generated by the machine learning, model and the machine learning algorithms are expressed, are actually shown in what we call an open box machine learning control panel. So when you log into BigPanda, and you actually, if you're an admin, you actually go into the admin section and you click on the correlation logic panel, and that actually shows you, what criteria the correlation logic is using to correlate your incidents. So that would be, for example, which data centers or which locations, for example, which long lat tags are you correlating against? What's the window of time in which you correlate these incidents together? What's the prioritization for what the correlated incidents look like, and so on and so forth. So all of the various, the 4, 5, 6 different criteria used to correlate the incidents are shown in a place that's, easily accessible in plain English. And then more importantly, you can then click on an edit button to actually tweak it as you need to.
Right. Okay. And I have a final question here. So, we hear about unknown unknowns and known knowns. What does this mean, and how important is this for NOCs in selecting an artificial intelligence or machine learning ops tools?
Yeah, so the known knowns and the unknown knowns, primarily talk about the types of incidents that happen, right? So anyone that spent, any amount of time in IT ops knows that you never fully know the type of incident that's going to, be connected to a critical outage or some kind of major performance problem, and therefore. In an ideal world, you always know, for example, based on past history, that you expect a certain type of an outage on a regular basis, or basically when something else happens. That I would say is more in the realm of the known knowns. And again, I'm talking very high level, loose terms. The unknown unknowns are the ones that you've never encountered before. It's just a perfect storm, right? With a perfect alert storm and a confluence of various factors that comes together. It's hard to predict. It could be a once in a 6 month, once in a 1 year type outage. And which is also the reason why, if you depend on a machine learning tool that needs to be trained with a large data set, that's actually going to help you catch all the known knowns. But every once in a while, when you encounter this unknown incident, that's when your model falls flat.
Okay. So those are actually all the questions that our attendees submitted, Mohan, so thank you for that. Again, I'd like to thank everyone for joining us today. Don't forget that you'll actually also be receiving a copy of this deck along with the recording in your inboxes by tomorrow, so please be on the lookout for that email. Secondly, if anything you heard today piqued your interest, or if you simply have something that you'd like to share with us, we'd love to hear from you. So please join the conversation with us via Twitter. You can either tweet us directly at BigPanda or include the official hashtag BigPandaWebinar. And finally, if you have any additional questions that we were not able to answer, please definitely reach out to us directly at info@bigpanda.io. And with that, I'd like to wish everyone a pleasant rest of your day.
Yeah, thank you, Reina, and thanks to all the attendees for your time. We hope this was useful. Hope to see you on the next one. Bye.